Hello, everyone, and welcome to our webinar, LangChain for Multimodal Apps, Chat with Text and Image Data. My name is Matt Brown, and I'll be your moderator today. One of my main jobs at SingleStore is to organize these weekly AI webinars. We do 2 per week, demoing data and AI use cases, new tools, and technologies. I post about these upcoming webinars every week, so if these topics are interesting to you, feel free to connect with me on LinkedIn to stay in the loop. I'd also love to hear your feedback or any ideas on topics that you'd like to see in our future sessions. Speaking of future sessions, click the next slide. You'll see that we have another great session coming up just on Wednesday. 2 days from now, on Wednesday, we will be presenting AI-powered personalized shopping and recommendation engines powered by Hugging Face and OpenAI Clip. You can come see a live demo on how these technologies can be used to get data insights from images and from web behavior in order to generate personalized shopping recommendations. It's very cool. Ingrid on our solutions engineering team developed this demo and application. I saw it a few days ago. It's very, very cool, generating insights from the images that people are browsing as they shop, and then recommending them items that they'd be interested in. Very cool. Hopefully you'll check it out. Put the short link on the screen. I'll put that in the chat in a minute, or you can just check that QR code, and that'll take you to the same place to RSVP. Getting back to today's topic, we would love for you to participate in the discussion throughout the session. There's a Zoom Q&A button at the bottom of your console. We have a mission statement to try to answer 100% of the questions that come in, even if we're busy during this session, which I think we will be. We've got a lot of registrants today. But as long as you log in using your name and email address, log into the Zoom, then we will get to your question either now or via email afterwards. We won't be answering any anonymous questions, so if you need to, feel free to log out, log back in with your name and email address, and we will get to your question. We'd also love for you to try out today's technology. In fact, anyone who tries this out today will be entered for a chance to win either new AirPods Pros or the new Meta Ray-Ban smart glasses. It'll be your choice if you are the winner. All you need to do to participate is visit this link that's on your screen. I'll put it in the chat in a minute and log in. If you already have a SingleStore account, you can just log in. If you don't have an account, we have a free shared tier. So you can just sign up, join that free tier, and check things out. And by signing up, you will be eligible for today's raffle. Let me introduce our speakers real quick. Alex is a growth engineer at SingleStore. His formal training was from the Stanford Computer Science program, and he has expertise in big data, machine learning, and AI. He is now a regular speaker at our weekly webinars. You may recognize him. Welcome, Alex. Good to see you again. The floor is now yours.
Thanks, Matt, for the intro. Hey, everybody. Glad to have everyone joining us here today to talk a bit about using LangChain for multimodal data. Before we jump into things, and just to make sure everyone kind of has the same even foundation, I wanted to talk a bit about some of the emerging architecture that we're seeing for LLM applications. And that's all really going to rest on this foundation of retrieval augmented generation, or RAG. Hopefully, for those of you who are returning to these webinars, you're already familiar with RAG and RAG-related concepts, but just so that everyone kind of has the same grip, RAG is essentially when we take an end user's query to an LLM. So say, for example, something that you type into the chat box into ChatGPT, we take that, we use that query to retrieve information that we then feed back into the LLM to make the LLM's response more accurate, more relevant, less likely to hallucinate. And we'll dive deeper into the mechanics of how we actually do that retrieval and what types of data we can retrieve. But that's the high-level picture that we're going to be looking at today. Kind of breaking down this RAG concept a bit more, we've been seeing this kind of AI stack architecture kind of become increasingly popular. And that's essentially this architecture of having at the kind of UI layer or front layer these, conversational UIs, your chat GPTs, your Bards, or now, Gemini, your, browser plugins and UI components, audio video interfaces. We see at the kind of foremost layer UI, which then hooks up into API endpoints. And API endpoints are something that you're going to be more familiar with if you're a developer. And so that's how you talk to, your LLM providers programmatically. That's how you're going to talk to your vector database provider programmatically. And if you're using a hosted vector database. And then finally, speaking of vector databases, we are actually not just a vector database, but we are a traditional relational managed database with vector database offerings. And you're going to also need behind your API endpoints a contextual data layer or contextual data store. And that's going to encapsulate not just, your relational data, your unstructured data, including your, PDFs, text, images, videos, audio, but also some of that compute that's going to actually allow you to access that data and process it, process it, ingest it, and query it. And this is just kind of a little bit of a deeper dive into contextual data and the contextual data layer. Just for the sake of time, we're going to be skipping this slide. So you may have noticed that I just mentioned a bit about unstructured data and storing unstructured data in your contextual data layer. When you store unstructured data and you want to use it in RAG, if you're familiar with RAG, you're going to be familiar with this process called vectorization or embedding. But just again, to make sure everyone has the same background, vectorization is essentially when we take any form of unstructured or even really structured data, and we we map it to what we call a vector, or we have a function that maps unstructured data to a vector. And a vector you can think of as basically just a list of numbers. And that list of numbers encodes the semantic meaning of the data that you're trying to represent. And the reason that we encode the semantic information of an unstructured piece of data in a vector is that vectors are a data type or data format that are very easily searchable over for the purposes of RAG, for the purposes of LLM context augmentation. And just some considerations for vectorization. Again, you're going to be wanting to use it generally for unstructured data, because for structured data, obviously you have things like structured query language, SQL, and that can kind of normally give you a much richer sort of query capability over your data set. But, if you're searching over a data set of pictures of cats, for example, it's a little, you may think or may realize that it's a little difficult to do, joins and selects over, just images, right? And that's where vectorization comes in. One last consideration for vectorization, you're going to want to be careful about vectorizing sensitive data or data that requires special access and then storing them in the same table or database. Really, the kind of partition of data that you're going to be querying over, storing them in the same partition, because as you'll see, when you query back over it, it can be difficult to make sure that you're only accessing the data that you are supposed to be accessing. And so it is important to make sure that you have kind of proper data access policies over the different data partitions that you're storing your vectorized data in. Great. Let's talk a little bit about multimodal capabilities. And that's, hopefully the reason that most of you are here today. And that's because we've seen, obviously, the first wave of LLMs was, this kind of text-based LLM we saw in, fall of 2022, and then later in spring of 2023, GPT 3.5, ChatGPT, and then later GPT-4, which, had these amazing text-only capabilities, but again, just text-only. And, later into 2023, and now really coming into the current day, we're seeing the widespread general availability of these multimodal LLMs. On the left here, you see just a screen grab from the Gemini demo, and that's one of the foremost multimodal LLMs that's coming out today. Today, we're going to be working with not Gemini, but the GPT-4 Vision multimodal LLM. That's arguably the kind of leading edge or bleeding edge multimodal LLM. Obviously, also, we have the Claude 3 family of models. We just did a webinar on that. If you're interested in working with Claude 3 specifically, I would highly recommend checking out that webinar that we just did last week. But really, the kind of motivation behind multimodal LLMs is, if you can think of a use case, if you can see these capabilities, you can almost certainly think of a use case where a multimodal LLM could be extremely useful across just any kind of number of industries. Just on the right here, we have some examples in healthcare, in autonomous driving. We're seeing kind of the dominance of multimodal LLMs and LLMs with image capabilities over traditional image classification techniques using machine learning, kind of pre-transformer image classification techniques. And so really, this is just at the absolute bleeding edge of what we're able to do in terms of just multimodal capabilities. And so that's why we're doing this webinar today, to hopefully give everyone, a set of tools to be able to start to work with, image and text data, and hopefully be able to fold that into, your own proprietary workflows and using multimodal capabilities on your own proprietary data. So we just talked about multimodal. We just talked about vectorization. As I mentioned before, vectorization is sort of a synonym for embeddings or embedding data, right? And when we're using multimodal LLMs, we're also oftentimes, though not always, going to want to be thinking about using multimodal embeddings. Multimodal embeddings are essentially embedding models that are not only able to embed text, but also able to embed image data. So a traditional text-only embedding model that maybe most of us are familiar with is OpenAI's text or Ada text embedding model, which is the only embedding model that they make available over their API. Actually, OpenAI has no multimodal embedding model available over API. It's text only. A few other, so once you have the text embedding models, you can use those for kind of multimodal workflows. And the way in which you use those is you essentially generate captions of the images in question using an image capable LLM and then embedding that caption, right? But that's usually a process that loses some information because you are kind of doing it in a multi-step process. You're going from image to image caption or image description, and then from the image description, you're getting a text embedding, right? Another method, and the method that we're going to be looking at today, is using a multimodal embedding model to embed both text and image data. In this case, we're just going to be embedding an image, though this multimodal model is also capable of embedding text directly into a vector format. So today, as I'll show everyone in the code demo, we'll be taking an image and then turning that into a vector. And when we have the vector, we can actually store it into our database. And in this case, we'll be using the SingleStore integration with LangChain. Just a few other kind of tidbits and notes here on multimodal embeddings. We're going to be using today the OpenClip model from OpenAI, which, not that important, but it stands for contrastive learning from image pre-training. The important takeaway from using OpenClip is that it is an open source model. And so you can download it from Hugging Face. You'll see how we actually download it and load it in and use it today. But you can actually use any number of open source models for multimodal embedding. You can go on Hugging Face and you can kind of search and filter by multimodal capabilities. and use kind of the models that fit your use case best. There's models that are fine-tuned for, medical data, for image classification purposes, kind of any number of use cases. Someone has probably fine-tuned an open source model. And so I would highly recommend checking out Hugging Face for the model that fits your use case best. We've actually just talked a little bit about multimodal LLMs. Just a quick kind of aside here on closed source versus open source. So we just talked a bit about, the bleeding edge multimodal LLMs, Claude 3, GPT-4 Vision, Gemini Ultra. You may not always actually need the, so-called bleeding edge of multimodal LLMs. And that's because they're very expensive to run. These multimodal LLMs are, some of the most expensive, if not the most expensive LLMs over API to run per token. You'll look at, you can look at the per token prices for, GPT-4 Vision or Claude 3 Opus or, Gemini Ultra, and you'll see, if you kind of run only exclusively on these kind of bleeding edge LLMs, maybe you'll get great performance, but you're going to be bleeding cash doing it. And that's where open source LLMs or kind of smaller parameter count multimodal LLMs can really come into play. We're not actually going to be looking at these today, but if you kind of if you use the code that I'm sharing with everyone today, everyone should have access to the code. I believe it's shared out on a GitHub link. Because we're using LangChain, you can very easily kind of hot swap, OpenAI or Claude 3 or Gemini, a bleeding edge multimodal LLM for, Fuyu, the Fuyu model from Adept or the Lava model from Meta, which are, two examples of open source multimodal LLMs that have text and image capabilities, but are not as computationally expensive to run. And in some cases, these models can actually even be run locally on even something like a personal laptop, which brings the kind of inference costs way, way down. And in many cases, if your task is simple enough, and that's really the key question to think about here, how complex is your task? If your task is simple enough, you will be able to get adequate performance out of these models, and you won't have to pay, the hundreds, thousands of dollars, or maybe even tens of thousands of dollars, depending on your volume, like for these bleeding edge LLMs. Another consideration is also fine-tuning these open source multimodal LLMs on your specific task. To my knowledge, you're not able to fine-tune the bleeding edge LLMs, and that's because oftentimes you just won't. They're just so big and so capable that they'll just work across any number of tasks. But fine-tuning a smaller model is, increasingly feasible with, less and less human labeled data, and can get you, in some cases, even better performance than a bleeding edge LLM. Great. So just now that we've kind of gotten all of this background here, I wanted to talk a bit about SingleStore. And, we are SingleStore. We're presenting this webinar, and SingleStore is a database to transact, analyze, and contextualize in real time, contextualize data in real time. And so just to give a bit of our spiel, we are deployed on-prem, in cloud, we're multi-cloud, and in hybrid environments. We can work row-based, we can work in columnar, and obviously we can also work with vector data, the data type that we've been talking about most. Just some kind of quick metrics on our customers, and to give everyone an idea of really what sets SingleStore apart from our competitors. Both traditional relational databases that have kind of sort of tacked on vector capabilities, and this new breed of vector-only databases. We are actually, and we pride ourselves on being a database that can be kind of the single source of truth for your company data, and to make that data accessible at the speeds that you need it accessible at. So for analytics, making the data accessible at super low latency, and with super fast ingest, but also kind of allowing that bottomless storage that we see from data lakes, right? And that's because we have this sort of proprietary architecture where data kind of first flows into memory, and that's where it's most quickly accessible. Finally, it kind of goes to local storage, SSDs, hard drives, and finally, it flows into kind of your, Amazon AWS S3 bucket, where it can kind of store, where you kind of have bottomless storage. Great. I'm going to skip over a little bit of this. Except for this part, SingleStore notebooks. SingleStore notebooks is a really exciting new capability that we have, begun rolling out more widely. And it's basically a way to interface directly with your SingleStore database. And we'll show this actually. I'm going to be showing the demo entirely in a SingleStore notebook. But essentially, it makes it really easy to connect to and work with the data in your database, in your SingleStore database. You can kind of do all the traditional things that you'd expect to be able to do on a Python Jupyter notebook. And you can do that all within the SingleStore portal immediately after setting up your SingleStore database, so you can start prototyping right away. Another really great function or another really great kind of function of SingleStore that I'd really like to point out to everyone to kind of get up and running with SingleStore notebooks as soon as possible is this thing called SingleStore Spaces. That's singlestore.com/spaces. If you're not sure what to do or where to begin with SingleStore notebooks, you can actually see on SingleStore Spaces, a number of kind of predefined and pre-vetted use cases, complete with code and explanation on both AI workflows and kind of just more general workflows. And you can import those into your SingleStore database and immediately start toying around or playing around with those demos on your personal data. Great. So I'm going to skip over this. So now we're going to get into the demo. Today we're going to be working with LangChain, which is probably a library that everyone here is familiar with. It's a Python framework that makes it super simple to interface with LLMs, interface with the data that you augment with LLMs. We are actually integrated into LangChain directly, and you'll kind of see how to work with our integration in LangChain very shortly. And yeah, let's go ahead and get into the code here. I'll take a moment here to just look at the Q&A, because I know that we probably got a good amount, and we do have a little bit of time before we look at the demo. Let's see. So let's see. So Mohammed asks, is there any way that the output response is multimodal other than images, the LLM generating graphs based on retrieved documents? So in principle, that is possible, though, the general kind of rule of thumb is as your output becomes more and more structured and well-defined. So in this case, you'd like to generate, graphs based on your retrieved documents. You're going to want to both, fine-tune your prompt and also consider actually fine-tuning an open source model on, input output pairs that you would like that are probably human labeled, right? And that's because, LLMs they're trained on, this vast corpus of data, and multimodal LLMs are, trained on, these image caption pairs, and they kind of get this understanding of how an image looks. But what they're not trained on usually is, an image plus text plus, some structured graph that you'd like to represent the input data, right? They can usually kind of have a reasonable first pass at something like that. But you'll notice very quickly that it's difficult to kind of get production level performance on these more specialized workflows. And so you're going to want to consider either, stepping up a grade to bleeding edge LLMs and seeing how that plays out for your data, and kind of just eating the cost and taking the hit to the wallet, or fine tuning a smaller open source multimodal LLM. Okay, yes. Yang asks, continuing with the fine-tuning context question, it's not very clear to me when exactly is fine-tuning needed when providing context is already enough. Great question. That ties back into a little bit of what I was just talking about. Fine-tuning you can think of as trying to shape the LLM's behavior and kind of its mapping of inputs and outputs in its weight space, as opposed to changing that, in context. So in your prompt, right? So you can think of fine tuning as, an LLM studying for a few weeks before a midterm to actually, do well on that midterm. And you can think of in context learning as, having the notes with you in an open note midterm, right? You're kind of rewiring your brain in that first process. In that second process, you're kind of checking against the notes that you brought with you as you kind of construct your response. Great. Okay, so many more questions. We won't be able to answer them all. I'd like to get to the demo. Let's take a look here. Great. So just want to make sure everyone can see my screen. So actually, before we get into the demo here, I wanted to show everybody really how easy it is to sign up for SingleStore and really get started and up and running with SingleStore Free, which is our new kind of free shared tier. If you just go to singlestore.com/cloud trial, you can sign up really quickly with your Google or Microsoft login, or kind of just providing your details here, and immediately get access to our free tier, which allows you to spin up a database, a workspace, and a database, and immediately get started running with some of our notebook capabilities and start working with data that you'd like to augment your LLM context with in a database that's capable of both traditional relational capabilities and vector capabilities. So once you are signed up and you've kind of filled out all these details here, you will kind of be put out onto this page here, which is kind of your start page, your getting started page. And from here, don't worry if you can't follow along. We'll be sharing the recording and the code, of course. But for those of you who are following along from this page, you're going to want to go to this kind of cloud tab here. You click group, and then you can spin up your first workspace. You can choose, on starter, we only host in AWS. But if you want to use some of your $600 of free credits, and you'd like to use a different cloud provider, that's no worries as well. You can select a standard workspace and deploy to any one of these three clouds. But once you are deployed and you've spun up your workspace, that's going to look a little something like this. And you're going to have your first workspace. You'll also kind of have a database, which is connected for you and connected to your first workspace. And that is actually all you need to get started with SingleStore and LangChain. Once your workspace is up and running, you can connect to it. So you're going to go ahead and, if you're not working within SingleStore spaces, you can get your kind of connection details from this kind of app tab. The first time you open this, you'll get your, connection password as well. But the really nice thing about working with SingleStore notebooks is that all those connection details are actually managed for you. So if you downloaded our notebook here, the way you're going to import it is by going to this develop tab or this develop dropdown, then going to the notebooks dropdown and going to personal or shared and importing your notebook from a file. So everyone should have access to the notebook that I shared out. But if you don't, that should be, I believe, being shared out in the chat.
I just put it in the chat, Alex.
Great. Yeah, that's going to be that GitHub notebook, and you can import it in here and start working with, inside of SingleStore. Great. So once you are imported and you've got your notebook in, here is going to be, all right, we'll use this one. Actually, see this one. Yeah, great. Okay. So once you're inside of the notebook's interface, you're going to want to make sure that you are connected to the correct workspace and database. In this case, I'm already connected. And this is just going to be installing some, override. Actually, I'm going to really quickly import the notebook that I just shared out. Yeah, I'm just going to really quick, actually, I'll show everyone this as I'm going through this. I'm just going to really quickly re-import it because I overwrote some changes that are important to just get the demo up and running. So let's see here, new notebook, import from file. This is going to be the same notebook that everyone is going to be working with. Great. And let's see. Just while these packages are installing, I'll also go ahead and put in my API key. Great. Okay, so just while we are installing some of these packages and getting, these, getting the database initialized, I'm just going to explain a little bit of what we're doing here. So these first two cells are essentially just going to be installing some of the libraries that we need to work with this data. I won't get into each library. Obviously, we have like LangChain and OpenAI here just for the sake of time. though, if there's questions that come up, I'm happy to get more into them. In this third cell here, we're actually going to be importing, this SingleStore database integration from LangChain, and also using the open clip embeddings that we just mentioned earlier, right? So these are going to be the multimodal embeddings that we were just talking about. The really nice thing, again, that I just mentioned with using SingleStore notebooks is that the the connection user, connection password, all of these connection details are actually provided for us as environment variables. And so we can just kind of just insert them in here and everything just sort of works. I just put in my API key here, and we're going to also be initializing, our table with, our embedding model, which in this case is open clip embeddings. And we're just going to give that a second to spin up while we take a look at the rest of this. So the image we're going to be taking a look at, oh, whoa, that is unexpected. 1 second. So actually what we'll do is we'll just kind of go into the locally saved version that I have here, because it seems we are running into some memory issues with the notebook. So I'm going to just reshare my screen. Great. Okay. So I'm going to just zoom this in a little bit so just everyone can see a little better, hopefully. Great. So this is just a locally shared version, or this is the exact same notebook that everyone has access to. And it should be running just fine on your machine locally, but just for, I think there might be some sort of issue on the back end. But I'm just going to be showing everyone this on my local machine so that you can kind of see what the sort of expected output is. So, once you've got your database spun up and your API keys inserted, you can finally start working with some image data, right? So in this case, we're actually going to be working with this sort of this very famous photograph of a woman during the kind of Depression era in the United States with two children next to her. You can already imagine sort of the capabilities that you can get, working with, obviously much more than one image, working with, proprietary data, but just for the purposes of this demonstration, we're going to be working with this image, where this kind of chunk of code just downloads our picture and saves it locally. This kind of just displays it for the purposes of the demonstration. And once you have, this is actually important, once you have your images, you can actually get, you can actually add them to your vector store using this argument, image URIs. And that's going to essentially, that's really just adding your kind of local image file paths, or taking your local file paths and then adding them to your vector store. I'm going to actually, we'll be sending out an updated, notebook here, because it looks like a code block above this that was supposed to be here did get inadvertently deleted. But once you've added your images to the vector store, because you've defined the embedding model in your kind of vector store initialization, in the backend, it does, or LangChain and SingleStore together does all of the embedding and storage for you, so that when you actually go back and you'd like to query your vector store for images that are similar to, something that you're looking for, you can go back in and retrieve the images that you're interested in, right? So hopefully everyone can see here, on running this query, we can.
Yeah, Alex, I don't know if your screen is frozen or if you might be sharing one tab
Oh,
versus another, but there we go. There we go.
Yeah,
here we
that's
go.
it.
Yeah. Oops. Sorry.
All
Whoa.
good.
How long was I sharing that for?
I think just like a minute
A
or
few
so.
minutes, I think.
Yeah.
Just go stream of questions there, Alex.
Oh
So
man. Okay. Super.
it's okay. I think you got it there.
Sorry about that. Okay, yes.
Uh,
So just I'm going back a little bit here just so everyone can see what we've been working through. So this just shows the image that we're working with. This is the add images function. And then this query is the way, and performing a similarity search on our vector store is the way that we're actually going to retrieve from our vector store. And then we're going to kind of get into the meat of how you actually work with image data with using multimodal LLMs in LangChain. And this is actually, this was for me the trickiest part to kind of get just right. And so happy to answer more questions on this. But essentially what we do once we have, a retrieved image, and so you can imagine, this is obviously a toy example with just one image and, one very specific query. But you can imagine, over a corpus of thousands of images, once you've retrieved the images that you think are most relevant to your query, what you're going to do is you're actually going to encode those retrieved images as base 64. And that's for those of us that are not familiar with what base 64 is, that's essentially a way to to losslessly compress the information contained in an image into a string of 64 characters, right? And that's going to give us a way to actually feed in the image data to our multimodal LLMs, which take image inputs as base 64 encoded images. So we have a few different functions here. We have, a function that encodes an image into base 64. This function gets our image URLs. And finally, this function actually prompts our multimodal LLM with our images, right? So we pass in a dictionary with images or image path URLs, and then we take the image and then actually we actually pass in the basics, or we take the image and then we create a new image message object which contains the image's base 64 inside of this image URL property. And that's actually how the LLM is able to sort of see your image, right? And finally, once we have these image messages in our message stream, we can actually pass in any additional text messages. So in our case, we're going to be asking the LLM to actually describe the image as an expert photographer would. Then we can kind of append all of our images or append all of our messages to one kind of message stream. And finally, we return that as one big message to the LLM. And this is actually one of the reasons why LangChain is really great to work with, is it allows you to kind of build these extensible and highly customizable, LLM chains, right? And create messages with, content that you can kind of customize programmatically, and that you can, you can use traditional programmatic, logic over. But once we've defined all of that, we're going to be using today, like I mentioned earlier, the GPT-4 Vision Preview model. Again, the great thing about LangChain is that, this model line can be swapped out in one line of code. You can use OpenAI models, you can use Claude models, you can use Google models. If you'd like to kind of scale down a bit, you can use open source models. And all of those kind of generally have the same kind of interfaces available to you. And so really very minimal refactoring is needed for just testing out different multimodal LLMs. So this is the way that we kind of this is the way that we're going to define our chain. This is our context, which gets us our image URLs. We have the question, and then finally we pass in as arguments the image prompt, which actually gives the images in a LLM readable format to our multimodal LLM. We pass in the model as an argument, and then a string output parser. And finally, after having defined all of this, we can give our final prompt, which is going to be run over the entire vector store. And then it's going to give us a text output, which is the LLM going to our vector store, retrieving an image, taking that image as an input, and then applying this prompt, describe the image as an expert photographer to that image, and finally giving us our output. And we can see here that the LLM is able to, or this is a saved output from earlier, but with the updated notebook that we'll be sharing out, you can see kind of our final output, which shows a very kind of surprising understanding from the LLM of the image in question, right? So we kind of see it's got all of this, it's got this understanding of all this detail in the image. And hopefully everyone here can imagine, you don't just need to kind of prompt for, unstructured outputs from the LLM. All of this kind of nuance and depth of understanding is available if you'd like to prompt, you'd like it to respond in, a JSON format to fill out, certain fields and to do classification or to do, grouping of images. Anyway, I wanted to give, these last 10 minutes or so to some of the questions. I'm sure we have many. Apologies for the hiccups that we ran into, but hopefully we'll be able to smooth some of these over. Let's see here. I'll go into the most recent questions, and we'll kind of work backwards from there. So let's see. So let's see. One of our viewers asks, over the period of time, will the LLM get self-trained on the data? How can we make the LLM learn while utilizing it? So that's a really good question. And that's sort of a yes and no. When you use the LLM, or in kind of in the sense that most people think of using an LLM, you are providing a prompt to it and then inferring from it, right? And that at that step and in that process, all of the weights of the LLM, or what you can think of as the brains of the LLM, are frozen in place and actually fixed. So, inferring from the same LLM over and over again does not actually change the LLM and kind of train it to kind of get better at understanding your data. Where you can kind of get that self-improving ability is when you are fine-tuning the LLM. So you are actually modifying the weights of the LLM. And the way that you fine-tune an LLM, in short, is you need input-output pairs that are of high quality. So you really need to understand and define crisply and have many examples of the inputs and ideal outputs that you would like from the data. And then you're going to you can use LangChain. You can use another library called LlamaIndex to actually fine tune your model. OpenAI allows for fine tuning of their GPT 3.5 model, I believe, and GPT-4 model, but that's over API. If you'd like to fine tune an open source model, you can do those with the kind of aforementioned open source libraries. But that's how you actually get the kind of self-improving capabilities that you're talking about here. Okay, great. All right. So Adam says, I'm assuming fine-tuning requires access to the LLM versus RAG is a connection between the two, or am I mistaken? So I'm just trying to parse out the kind of question being asked here. Fine-tuning, so the first part of the question, fine-tuning does require either kind of direct access to the model weights or the model provider allowing for fine-tuning of the model that they're serving over an API. So both those examples I mentioned before, open source LLMs, that's very easily fine-tunable because by definition you have access to the model weights. And some model providers like OpenAI are increasingly making their models open to fine-tuning. And so that is also another way that you can fine-tune an LLM, though it's not kind of the most direct access that you can get to it. RAG is a connection between the two. I'm not sure what is meant by that question. So if you'd like more clarification there, I definitely do ask in the Q&A and I can clarify. Akmal, did you see any questions that stuck out to you that you felt like should be answered live or?
You on mute, Akmal?
Yeah, I think there was a fair few about fine-tuning, Alex, and also about in the sense of the data that you're giving to the LLM for which you want to kind of extend it for RAG. How about adding that to the body of knowledge for the LLM? I mean, for commercial LLMs, if it's something proprietary to you, you don't want to do that. Neither do they do that automatically. OpenAI, for example, I think their default is that they do not keep your data unless that you give them specific permission to do so. In any case, I mean, they get updated every 6 months or so. But for this kind of thing, if you're building your own internally, then of course it's a no-brainer. I mean, of course you would do that. That is something to improve the quality of the questions that it can answer, the documents, the knowledge that it gains. It's learning all the time. So I think just a little bit on that, on the fine-tuning as well. I mean, do you do that as well as the retrieval or augmented generation? Of course. I mean, there's many things there. It's an architectural thing. It's not a magic wand. There are things you have to think about, just like you do with any software development, that there are issues to consider and constraints in terms of resources and so on, and what you can achieve. But yeah, lots of things to think about there. I think no one's come up with a good development methodology that I've come across yet. LLMs. So.
Hey, Alex, I've got a question for you. This one is from Ben Wang, and I think he's thinking about, which tools to use for which use cases. And I ended up sharing with him your Claude webinar from last week. And he's just followed up and said, quick follow up on that. I've looked at that. It seems like, the page is being treated as an image for Claude to read. Isn't that inefficient or unnecessary for complex PDFs? Shouldn't we dissect the PDF into text, table, figure, treat each separately? I've tried Claude 3 for complicated tables. The extraction is actually not so good. And I remember you talked about this a little bit in your Q&A on like how Claude is doing an image versus. So I wonder if you could just talk about that for a second, or any recommendations for Ben.
Yeah, so Great observation. The approach we do take in kind of the last webinar is, I would say, more of a naive approach. It's, you know, definitely kind of, it's kind of the first step in what I would think of as kind of a multi-step approach you would take to actually getting LLMs and LLMs into a production workflow, right? And the first step is going to always be what is the best possible performance I can get from the best possible model on my specific task. And, with hopefully minimal prompting, minimal kind of pre-processing of the data in question, right? If you're not able to kind of get good enough performance from there, then you can kind of consider using, some of these more advanced, PDF pre-processing libraries. I just saw one recently that, if I find this link before the webinar is over, which is just in a few minutes, so it's unlikely, but there's, any number of PDF pre-processing libraries that you can employ before passing in chunks of data that these pre-processing libraries create chunks of data that you can then embed and then retrieve over, and that might get you better performance. But yeah, you're going to want to kind of think about kind of working backwards from, the best possible model with the least possible, data pre-processing, and then kind of stepping down to see how much more pre-processing you want to do. Because I don't know about you, I'm a little lazy. I'd like to do, the minimal amount of pre-processing for, kind of the best possible performance at the best possible price point.
Awesome. Akmal, do you see any questions unanswered that you'd like to get to? We should probably maybe do one or two more questions before I announce the raffle winner for today and just wrap things up. And same question to you, Alex, but I'll go to Akmal first. Anything, Akmal, you want to mention?
Yes, I think there was a couple of questions also about the credits for SingleStore. So keep in mind, I think you may have mentioned this, Alex, and forgive me if I missed it, but there is a free tier for which you don't need credits. If you launch that, you're good to go, and that gives you pretty good amount of processing power. I think it's 15 gig of memory as well. And if you do need the $600 credits, because you want a bit more control in terms of the resources you want to use, again, you can use that wisely. I've still got credits from the time I joined the company over 2.5 years ago. And at that time, they were just $500 worth of credits. And if you need more, just reach out to us. Then we can bump up your credits as well. Just team@singlestore.com. It's probably the simplest way. And we can pass that on. And the cloud team will take care of that. So I think that was the main thing, Matt.
Great. Alex, how about you? One last chance before I serve up the raffle winner. Any last questions you want to get to?
Yeah, so I see a question here from Yang asking, can I please go through the steps of the RAG pipeline briefly again? At which stage is the base64 encoding involved? Why do you need this encoding if the image is vectorized? Really great question. So I'm just going to go and share again. The point at which we actually re-encode the image into base64 is in this function, and then we actually append. So this function encode image base64, and then we actually append that encoded image into a message that we end up, building into a larger message that we actually end up sending to the LLM. And you can see that here. This is appended as an image message. Any text messages that we have here are also appended. And finally, there's this class called a human message in LangChain, which is capable of basically containing all of these messages kind of appended together. And the reason that we do this is because, after we vectorize our images or embed our images in order to be able to later retrieve them semantically. So by just providing a, query, some kind of fuzzy query that we can then match against our database of images and retrieve from. Once we have retrieved the image, the LLM still needs to be able to see it, so to speak. And the way that it does that is by looking at base 64 encoded text, which encodes the image, right? And so it's sort of a two-step process where you need to grab the images that you'd like the LM to be able to understand, and then you convert it into this intermediate data type that the LM is actually able to take as an input. It's the right input shape for the LM. But good question.
Awesome. Thanks, Alex. I'll do this quick. Reminder, Wednesday, we've got the AI-powered personalized shopping and recommendation engine with Hugging Face. Ingrid is going to be presenting that. This is turning into kind of like an OpenAI clip week because I know, Akmal, you're going to be doing the video embeddings with the Python notebook using OpenAI clip, I think, too. In a few days. But first is this personalized shopping one. So check it out. I've just put the link in the chat. We'd love to see you there on Wednesday. You can just RSVP at that link. And then the announcement that you've been waiting for, today's raffle winner goes to Lou Zhu, Corporate Vice President of Data Science at New York Life in Boston. Congrats, Lou. Thank you for joining us. If that's not you, don't give up. We're going to give out one more AirPods or Meta Ray-Bans by the end of today to someone who has tried out Alex's demo. So again, I've just put the link in the chat for you to sign up and be eligible for trying that out. We put the GitHub in the chat, but that will also be in the email. Everyone who registers for this webinar will get the video recording, the GitHub, any related resources. So keep an eye on your inbox for that. Thank you, Alex, for an awesome session. Thank you, Akmal, for Q&A as usual. And thank you to our audience for joining us today. Hopefully we'll see you at the next one on Wednesday. Thanks, everyone. Bye-bye.
Thanks, everyone.